right, let's dive into what is, no joke, one of the most profound and just mind-bending experiments in the history of science. This is a story that really makes you question the very nature of reality itself. You know, believe it or not, there's this one single experiment that is the absolute bedrock of all of quantum mechanics. And I'm not talking about something that just, added a new fact to the textbooks. No, this thing completely upended our common sense idea of how the universe is supposed to work. Yeah, that's right. It was so bizarre, so counterintuitive, that it kicked off this decades-long debate with the greatest minds in physics, including a very, very skeptical Albert Einstein. And what this experiment reveals, well, it's something that just sounds impossible. It shows us, but at the most fundamental level, the universe seems to play by two totally different sets of rules. One set for when we're not looking, and a completely different one for when we are. The simple act of looking at something changes what it does? I mean, how is that even possible? Okay, let's break it all down. Okay, so first, we're going to start with the part of this experiment that makes perfect common sense. This is how we all think the world should work. So picture this setup. It's super simple. You've got a solid wall with two little narrow slits cut into it. And behind that wall, there's a screen, kind of like a movie screen, that'll show us what happens. And now, all we're going to do is shine a light through those two slits. So what shows up on the screen? Well, it's not just two bright lines, which is kind of what you might expect. Instead, you get this beautiful striped pattern, all these bright and dark bands. Okay, so this is called an interference pattern, and it happens because light is acting like a wave. Think about it. As the waves go through each slit, they spread out and start to interact with each other. Where two wave crests meet up, that's where you see the bright bands. They get stronger. And where a crest meets a trough, that's where you get the dark bands. They just cancel each other out. So far, so good. This is all perfectly logical, exactly what you'd expect from waves. But this is where things get weird. This is where our understanding of reality just takes a sharp left turn. Physicists decided, hey, let's try this again. But instead of using waves of light, they used particles, specifically electrons. Now think about it. If you're firing tiny little particles, like, I don't know, tiny paintballs, at two slits, what would you expect? You'd expect to see just two stripes on the screen behind it, right? One for each slit. But that is not what happened. Incredibly, what they saw was the exact same interference pattern they got with the light waves. This result was just baffling. So they thought, okay, maybe the electrons are bumping into each other. So they fired them one by one. And yet, over time, the same wave pattern built up. This suggests something absolutely insane, that each individual electron was somehow going through both slits at the same time, acting like a wave and interfering with itself. Wild. I mean, this just flies in the face of everything we thought we knew. So naturally, the scientists wanted to get a closer look. They wanted to see what was actually going on. Which path was each electron really taking? They asked a super simple, logical question. Which slit does the electron actually go through? The left one or the right one? I mean, it's got to be one or the other, right? So to get an answer, they put a little detector right next to the slits. This little gadget would just tell them, yep, this electron went through the left slit, or nope, this one went through the right. And the second they turned that detector on, the instant they started watching, everything changed. The interference pattern, it just vanished. Poof, gone. And in its place, the two simple stripes they expected to see in the first place. And this right here is the great mystery. It's like nature has two different modes. When you're not looking, the electron acts like a wave of pure possibility, exploring every path it could possibly take all at once. But the moment you look at it, the moment you observe it, it's forced to pick one and act like a good old-fashioned particle. The act of measuring it literally changed what it did. So what in the world is the explanation for this? How can that be? Well, it meant we needed a whole new way of looking at physics. This leads us to a huge idea in quantum mechanics called the wave function. The idea is, before you measure it, a particle like an electron isn't in any one specific place. It exists as this cloud of probabilities, describing all the places it could be, and that cloud, that probability wave, is what goes through both slits and creates the interference. But the act of looking, of measuring, It forces that entire cloud to instantly collapse down to just one single definite spot. You know, the brilliant physicist Richard Feynman once said that this experiment contains the only mystery, because if you can wrap your head around this, the idea that a particle takes every possible path at once until you look at it, then you've basically grasped the central, weird, and wonderful heart of the quantum world. Now, you might be sitting there thinking, okay, this is a cool, abstract little puzzle for physicists, but the rules that this mystery uncovered, they are the absolute foundation of our modern world. I mean, understanding this whole wave particle thing isn't just for fun. It's the reason we have transistors, the tiny switches inside every computer and smartphone you've ever used. It's how we get lasers. It's how electron microscopes work. The entire world of modern electronics, and even the future of quantum computing, it all comes down to understanding and using this bizarre quantum behavior. And get this, the debate over what it all really means is still going on. You've got wild ideas like the many worlds interpretation, which says that every time a choice is made, the universe literally splits, and every possible outcome happens in its own parallel reality. Then you have other ideas like pilot wave theory or decoherence. The crazy thing is, we still don't have one single answer that everyone agrees on. So in the end, the double-slit experiment just blew up our comfortable, old-school view of the world. It showed us that at the deepest, most fundamental level, reality isn't made of tiny, solid things like little billiard balls. It's more like a shimmering, probabilistic dance, a universe made of possibilities, just waiting for someone like us to look and bring one of those possibilities into reality.